Okay guys, so in this video let's talk about binary search. Okay, in the previous video we have talked about linear search, right? So recall the best case time complexity and worst case time complexity of linear search algorithm. It will take O of n, right? That's the worst case time complexity. Okay, so linear time complexity. Okay, worst time is O of n for linear search. Okay, LS. Here I'm gonna teach you binary search, which is way much simpler than the linear search. Okay, and it's going to take very lesser time than the linear search. How it is possible? And I'll tell you why. There is no need for me to compare each and every element. So no need to examine each and every element in binary search. No need to examine each and every element, right? You can directly get the element. How it is possible? And that's how binary search magic works. Okay, so let's see. Okay, let's take an example. Fine. So this is my array, let's assume, and let's say I have elements, say 10, 20, 30, 40, 50, right? So I have 5 elements. Let's go with that, or I can go for one more element. Okay, before that, let me have the element in some random order, guys, because I have been telling you about only the sorted elements, right? Let me have elements in random order, so that that is one more point here to understand. Right. Okay, let's say 7, 5, 13, 15, 17, 11. Okay, so these are my elements. Okay, and this binary search has a prerequisite. Okay, this has a requirement. What is the requirement? You have to sort the array. Okay, you have to sort the array before you locate any element. Before you locate, you have to sort the array. Otherwise it won't work. The binary search algorithm won't work. The binary search algorithm demands that the array should be sorted. Okay, and you can see that this array is not sorted, so first step would be sorting the array. So you can use sorting techniques, which I will be teaching you later. So let us assume the sorted array now. So sorted array, okay, that's the first technique, right? So what will be sorted array? 5, 7, 11, 13, 15 and 17, right? So this is my sorted array. Okay, then only you can apply your algorithm. Okay, the algorithm goes like that. Okay, so without having the sorted array you can't proceed, right? All right, so now what you have to do, you just have to choose the last element, the first element and the mid element of the uh, array. Okay, let's say my mid element is 13. Okay, the middle element. Okay, so this array has 6 elements, so the mid element would be 6 plus 1 divided by 2. So 7 by 2 will become 3.5. So either you can take third element or the fourth element as the middle element. Okay, since this array has even number of elements, this goes a problem like that. If the array has odd number of elements, then you can exactly locate the middle element, right? And you're getting it right. So I'm choosing this as my middle element. So this is my first element, this is my last element, and this is my middle element. This is the second step, guys. First step is sorting, whereas second step is choosing the first, middle and the last element, right? So you have to do like that. Okay, the third step goes like this. After choosing the middle element, let's say I'm searching for a particular element. Let's have the search element first. I'm searching for 11. Okay, I'm searching for 11. All right, so the third step would be comparing your middle element and the element which you are searching for. Okay, understand that the element which you are searching for is 11, and you have to compare the middle element. Okay, so the middle element, you have to compare whether the middle element is greater than or lesser than your searching element. Okay, let's say my middle element is here is 13, so I have to check whether 13 is greater than 11 or lesser than 11. All right, so go for one check if 13 is greater than 11 or lesser than 11. Okay, so here the 13 is greater than 11, right? 13 is greater than 11, so this is true, which means my middle element is greater than the element I am searching for. Okay, the middle element is greater than the element I am searching for. In other words, I could say the element which I am searching for is lesser than the middle element. Okay, that is 11, which is lesser than the middle element. That's the correct way of arguing. Okay, then what I have to do, if that is the case, then it's very simple for me. If that is the case, then here we have found that the element which we are searching for is lesser than the middle element, right? So if that is the case, then there is no need to search this particular part, right? Understand that if the element that you are searching for is lesser than the middle element, then there is no need to search this particular part, right? You can search only for this part. Okay, you can neglect this side of the array. Okay, because the array is in sorted order, right? So you can neglect this side of array. Okay, now what you have to do, to neglect this side of array, you have to make 13 as your last element. That's it, 13 as your last element. So 5, 7, 11, 13. So this is my last element, this is my first element. Now again you have to choose your middle element. Let's say my middle element is you can choose, right? You can choose any one element because it's another even number of elements. You can choose, say 7 is my middle element. Again you have to compare. Middle element is greater than element you are searching, or middle element is lesser than the element you are searching. It is obviously greater than the element you are searching, right? So this part can be omitted. This side of the part can be omitted because the middle element is greater than the element that you are searching. I mean, the element which you are searching is greater than the middle element, right? Again you have to choose your middle element, then compare the element which you are searching, whether it is greater than the middle element or the element which you are searching which is lesser than the middle element. Of course, the element which you are searching, which is 11, is greater than the middle element. Middle element here is 7. Okay, I have chosen middle element as 7. So if 11 is greater than 7, if that is the case, then there is no need to search this part of array. Even if you have elements here, there is no need to search, right? Because you know that your 11 is greater than your middle element, right? So what you have to do here is you just have to make this as your first element now. Okay, make this as your first element. Again choose your middle element. Now it is 11. Okay, and compare your middle element. Middle element here it is equal to 11. Then stop the process. Okay, middle element now equal to 11 and stop the process. That's it. So here the main point to understand here is the middle element comparison. Okay, and if the middle element once you have encountered that is equal to the element that you are searching for, here you have chosen 11 as middle element and that is the element that you are searching for, then stop the process. That's it. Okay, let me quickly recall the algorithm once again. Alright, so I'll have a sorted array first. So first of all you have to sort the array. So let me say 1, 2, 3, 4, 5, 6, 7, 8 and 9, right? So I have 9 elements. I'm searching for say 3. Okay, I'm searching for 3. I'm searching for 3. First, what is the step? Choose your first element, last element and the middle element, which is 5 here, right? And the element which I am searching for 3, obviously it is not equal to the middle element, but it is lesser than the middle element, right? 3 is lesser than the middle element. Then ignore this part. If so make this middle element as the last element. Search only this array. Okay, make 5 as your last element. Okay, after that you have to choose your middle element again. So let me choose 3 as my middle element, right? And the element which I am searching for is also 3 and that is equal to the middle element, right? So here it is middle element. So stop the process. That's it. Okay, so it's very simple algorithm, right? So you have to omit, you can omit one particular side of array depending upon the comparison, whether the middle element is greater than the element which you are searching or it is less than the element which you are searching, right? So based on that you can omit one side of the array, and after that you have to use that array, first element, last element, and again choose the middle element, right? You can go for that, and this is a very easy process. Again, we are not, the important point to note here is we are not searching the whole array, right? We are not searching the whole array. We are omitting, we are actually omitting one side of the array. So at the end of the day, we are not actually traversing, examining each and every element. Here you can see there are 9 elements, but we have once made one comparison, we have actually omitted one side of the array, right? So we are not searching the whole array. So this method has a time complexity O of log n, which is much better than O of n in case of linear search. Okay, so O of log n is the worst case time complexity of this particular algorithm. Because why it is O of log n means, log n where it will come when the problem is cut off by a division. Problem is cut off by a division, which means when your problem is is getting cut off by a division. Say the first I'm making 5 comparison, in the next step I'm making only 2. Okay, let's go for this example. In the first step I'm making 6 comparison, in the next step I'm making only 3, in the next step I'm making only 1. So the problem is getting way easier, right? It is getting reduced. Okay, the steps, number of steps is getting reduced. That's why it is called as problem is cut off by a division. So the idea here is log n. Okay, the worst case time complexity. Again, the best case time complexity would be O of n. Okay, why? Where it comes when you search for the element which is exactly the middle element. Let's say this is my sorted array. Okay, so first of all you have to sort the array, don't forget that. Let's say I'm searching for, my middle element is 3, this is first element, this is last element. Let's say I'm searching for 3 alone. So in the first step itself I'll get the answer, right? So I'm searching for the 3, that's the middle element, so I'll get the answer. So I'll execute this program only one time, that's it, right? O of 1. And it depends upon the cases that we are going to give, it depends upon the example that we are going to give to the program. Okay, it will work in worst case, or it can also go to best case in sometimes. That's all about binary search. I hope you have understood this. Thanks a lot.